So fractional equations, which we've done some of, just clearing the fractions, getting rid of the denominators, and then overlapping triangles. So kind of like that number 20, but with some different things going on that we're asked to do with those. So first one, let's solve this thing. Somebody tell me what you think we ought to do here. I already described the strategy. I guess I get to just start calling on people. Lucas, thank you. Nah, too much trouble. Layden? We look for the least common denominator of those denominators because I don't really want to have to add 4/3 plus a fourth. It's too much work. So what is the least common denominator I could have? Everybody. 12. So I'm going to multiply everything in this problem by 12. Doesn't matter which side I write it on. When I multiply 12 times the first one, the 12 over the 4 becomes a 3. And usually take what you're multiplying by along with the denominator and simplify that first. And then, so the 12 over the 4 becomes a 3, and we still have the 2x plus 3. Since it had a plus in it, we need to put parentheses around it. So remember, all of that numerator gets multiplied by 3. Then we have 12 times minus 4/3, plus times minus is a minus. Multiply this one. 12 over the denominator first is how much? 4, and then times the original 4. You could write that down all in one step if you wanted to. I'm writing it out just to be clearer. And then finally, don't forget to multiply it by the right-hand side because we have to multiply both sides by the same thing. And what is 12 times a fourth going to give us, everybody? 3. So now, help me distribute this thing. Milo? And then we have the minus 16 equals 3. What is 9 minus 16, everyone? -7. So I have a -7 on the left, so I'm going to add 7 to get rid of it. Add 7 on the right. And I have 6x is 10. Divide both sides by 6. What is x? X would be 5/3. Thumbs up or down for that example. Okay, next one. So this invisible denominator is a 1. So what do I need to multiply this problem by? Need to multiply this one by 15. When I do that, 15 over 3 is how much? How much? 5 that gets multiplied by the original numerator. Then I have 15 times a minus and something that's over the 5. So the plus times the minus is going to be a minus. And what's 15 over 5 going to be, everybody? 3. And then that needs to be multiplied by the whole numerator, which has a minus sign in it. So I need to put parentheses around it to show that I need to distribute. And then finally, what do I get for the right-hand side, Max? So far, so good. Okay, so 20x. Now I need to be careful. And this is part of why I really want that parentheses there. Minus in front of a parentheses, the minus goes with it when we distribute. -3 times +7 is -21. But -3 times -2x is how much, Manas? So plus the 6x. And then that still equals the 30. Finish that real fast for me. It's not the nicest number in the world. So Anna, how many x's do I have? So 26 x's. And if I add the 21 to both sides, what do I have, Layden? So x is 51 over 26, then I don't think that can reduce. Questions? Everybody feel okay with clearing the fractions with these fractional equations? Okay, overlapping triangles. So we may have things like this. Sometimes it helps to redraw the triangles separately. You don't have to, but I want you to keep in mind that that may help. So I could redraw these. Up at the top, I've got this little triangle, 2, 3, and 4. If I draw the big triangle, I have to be a little bit careful because this side is 3 plus 2 or 5. This side is 3 plus x. And the bottom is y. Everybody see where that comes from? Okay, they tell us that these two angles are congruent. So I'm going to mark that in my two little triangles. We'd sure like these triangles to be similar because we know we can set up ratios of corresponding sides to solve. But one angle isn't enough to say that they're similar. However, that angle is that angle, right? And I'm going to put a little circle on it. That angle is exactly this very same identical angle right there, isn't it? But it is also this very same identical angle right there. Thumbs up, thumbs down. Does everybody see that? Now, AA does what? Michael? If we have AA, if we have two sets of angles, what do we know about the third set? So they have to also be congruent because we know AA implies AAA. So we know we have similar triangles. Now it is okay to set up our ratios. So we do, remember, corresponding sides are across from the congruent angles. So I can go first across from the angle that they give me. I'll do the little one over the big one. 2 over 5 in the top triangle. Then if I go across from the one I marked in green, that is 4 over y. And then if I go across from the third one, which I didn't put a mark on, that's going to be 3 over 3 plus x. Check my work. Does that look right to everybody? Okay, I want you to solve the two equations that you get from that. One of them is 2/5 equals 3 over 3 plus x. The other one is 2/5 equals 4y. All right, let's start with y just because it's a little bit easier. Khadijah, what'd you get? Thumbs up or down for y equals 10. Let's see if I can get the same thing. Cross product, we've got 2y equals 5 times 4. Divide both sides by 2. And yes, I agree with you that y is 10. And let's see, Naomi, what did you get for x? 9/2, 4.5, thumbs up, thumbs down. How many got that? Okay, that's most of you. Let's see if I can get the same thing with that one as well. That's going to give the 3 times the 5 is 15. And then I need the 2 times the 3 plus x. So I have 6 plus 2x is 15. If I subtract 6, I have 9. And if I divide both sides by 2, I also have x is 9/2. Questions, Chloe? 2 in the first half. You did 15 halves? Yes, but then you've got to do 15 halves minus 3 to get x, and you're doing a fraction problem. It isn't wrong, but I always try not to have to do fractions if I don't have to. Any other questions? All right, grab your whiteboards. Let's let you do a little bit of extra practice.